So now we try to derive some consequences from Maxwell's equations. The Maxwell equation without charge and current. Okay. So we substitute these two answers to the Maxwell equations. Remember that we have learned in chapter 1 that I told you that for plane wave we can replace the del operator by just minus ik, and we can replace the time derivative by I omega. Okay, this can be easily verified by, for example, curl E. Now, if we calculate curl E, you encounter this kind of calculation: E0 exp I omega t minus k dot r. Okay. So remember that in vector analysis, if we encounter a vector field A multiply a scalar f, then this operation can be expanded as gradient f cross A plus f times curl A. Okay. Now this is just this form. Okay, and this exponential vector is the f, and this is just the A field. So curl E contains two parts. The first part is gradient exponential I omega t minus k dot r, and across the E0. The other part is exponential I omega t minus k dot r times curl E0. However, here E0 and H0 are constant vectors. So the curl of constant vector is 0. And del operate to this phase vector. Phase vector, you encounter exponential minus I k dot r. Minus I k dot r means minus I kx times x plus ky times y plus kz times z. And the del contains three possible partial derivatives. If you apply the x partial derivative, this operation gives you minus ikx, okay, and the times the unit vector along the x direction. Similarly, for the y partial derivative, you get minus iky times the unit vector along the y direction, and similarly for the z component. So finally, you get minus ik times this vector cross E0. So finally, we have the phase vector I omega t minus k dot r times minus ik cross E0. And this phase vector combined with E0 is the original E. Okay, so we get minus ik cross E. Okay, that's why we can replace del by minus ik. Similarly, for time derivative is much is even simpler than this operation because we do not need to apply this formula. Okay, so time derivative, you just get a factor I omega. So when we encounter plane wave, we can just do this replacement to get the results we want. Okay. So according to the first equation, what I get is k dot d equal to 0. 把 I 负 I 去掉了。And the second equation tells us that k dot b, which is k dot mu h. 好，我们现在假设 we assume that the medium is anisotropic with respect to the E field, but isotropic with respect to the magnetic field. Okay, so this mu is just the scalar. Okay, k dot h 0. So in fact, we find that k dot b is 0 and the k dot h is also 0. And then the third equation tells us that minus ik cross E is equal to minus I omega B or minus I omega mu h. Okay, and I can write this. 我把负 I 拿掉了啊，因为大家都有负 I。Can write down the result here. And finally we have k cross h equal to minus omega d, which is just the minus omega E epsilon dot E. Okay. 好，我们得到了这几个关系式。那我们现在来画个图，这个图很重要啊，就是在 anisotropic 介质里面呢，这些向量的方向上的关系啊。先来画个图啊。So suppose this is the propagation direction. This is the k vector, direction of the k vector. Then according to this result, we know that the D vector is perpendicular to K vector. 它们垂直。And according to this and this equations, we also know that H vector is perpendicular to K vector. However, if we just use the first two equations, we do not know the direction, the relation between the direction of H and the direction of D. Okay, we must see equation 3 and 4 to know the details. Okay. According to equation 4, this equation implies that this equation and this equation. Okay. 那现在有一个问题是说，我们前面说过，说这个 anisotropic 介质里面，电场跟第一场通常不平行啊。We have already learned that in general in anisotropic medium the D vector and E vector are along the different direction. So we might draw the E vector like this. Here, E vector has a direction different from the D vector. Okay, and we know that K cross E is proportional to H. So we can draw the direction H and B. And the final equation tells us that K cross H is along this direction. This direction is the direction minus D. Okay, so now we have learned the final result. The final result, we know that D is perpendicular to H, and the K is perpendicular to H. OK， 好，就说根据第一式是 D 和 K 垂直，根据这一式是 K 和 H 垂直，但是在这两式之间，你不知道 D 和 H 的关系是什么。好，但是你根据这一式，你知道 D 跟 H 是垂直的。好，因为你一个向量 cross 之后出来的东西，会跟原来这两个向量的任何一个都垂直。好 ，the cross operation, the result is perpendicular to K and also perpendicular to H 啊 ，D 会跟 K 跟 H 都垂直，所以这时候代表的是说 D 垂直于 KH 平面啊 ，D vector is perpendicular to the KH plane 啊 ，D is perpendicular to the KH plane. Okay, and K is perpendicular to H. 对不对？所以最后你就知道说 ，D 垂直 K 垂直 H 啊 ，H 垂直 K 啊，所以这三个向量啊 ，D 垂直 K 垂直 H， 然后 H 又垂直于 D， 好，这三个两两垂直。These three vectors are orthogonal to each other. 但是现在呢，你能知道的是说 ，H 会垂直于 K1 平面啊 ，H is perpendicular to the K1 plane, according to this equation 啊 ，H 会跟 k 垂直，也会跟 e 垂直。所以这边暗示你是什么东西呢？这个 e 啊，它落在 dk 平面上。So this figure tells us that E is in the KD plane. 好，电场 E 的方向，电场 E 躺在 KD 平面上，躺在这个平面上 ，KD plane。KD plane. E is in the KD plane. Okay. So in general, we have in general the E vector is along a direction different from the direction of D vector. Okay. 好，那这边有一个有趣的事情就来了啊，就是说 K vector 所代表的是相位的传播，对不对？好 ，the K vector represent the propagation of phase, okay, represent the direction of the propagation of the wave phase. Wave phase propagate along the k direction. And you have learned that in chapter 1, we have a quantity called pointing vector. Pointing vector is nothing but the energy flow. Pointing vector 其实就代表能量的流动嘛，能量流动。So energy propagate along the direction of pointing vector. So if you see this figure, what is the direction of pointing vector? The pointing vector is along a direction perpendicular to the EH plane. Because pointing vector， 我这边可以暂时把它擦掉。Pointing vector time average 的 pointing vector S is 1/2 real part E cross H star， 或者是，总之就是说，你的这个 S 呢是垂直于 E H star， 那 H star 其实就是 H 啦，只是时间上的震荡，所以你的 pointing vector 会指向这样一个东西，指向这样一个方向，So you find that the pointing vector point to a direction different from the direction of K. Okay. In isotropic medium, we have pointing vector parallel to the K vector. So the phase and energy propagate along the same line. However, in anisotropic medium, in general, phase propagate along this direction. The pointing vector propagate along a different direction. Okay. So they have different propagation direction. 这边的话有一个角度可能画的没有很好但是这边实际上是这样。假设这个夹角叫做阿法的话if this angle called alpha, then this is also alpha. Okay, 就是说 the angle between D and E is the same as the angle between K and S. Okay, 就是说它们之间其实是 in general 是不同方向。In general, the pointing vector and the K vector have different directions. Okay. and the angle between the E vector and D vector is the same as the angle between the K vector and the pointing vector. OK， 好，那接下来我们要来研究一下这个 dispersion relation 哈。Now, I recommend you to memorize this figure, which will be very helpful. So now we have these two equations to be used to derive the dispersion relation, the relation between omega and the K. So I calculate K cross E. This gives us omega mu K cross H. And I can substitute the final equation into this equation and get us minus omega squared mu D. And I can write this as mu epsilon dot E. Okay. So this equation will tells us the dispersion relation, which means the relation between K and omega. 我们可以看一个从前在 isotropic 介词里面我们怎么得到 dispersion relation。好，我们先回顾一下。好，let me recall how we derived the relation between K and omega in an isotropic medium。我们现在是回顾哈 in a isotropic medium. In isotropic medium, we have K cross E equal to minus omega squared mu times epsilon E. Here E is a scalar. Or is a constant. 我们先看简单的 case 哈。For isotropic medium, this epsilon becomes a simple constant. Okay, so in this situation, the left-hand side, we find the result is K dot E times K minus K dot K times E. According to vector analysis, we have this formula. However, in isotropic medium, since E is parallel to D. So K dot D is 0, so K dot E is also 0. So we get 0 and the minus K squared times E. And the right hand side, we get minus omega squared mu epsilon times E. So these two parts is equal to each other, so we get K squared is equal to omega squared mu times epsilon. And this is just omega squared mu epsilon 0 times epsilon over epsilon 0. Okay, and for non-magnetic material, in this textbook, we always assume that mu is very close to mu 0, the mu in the vacuum. So I can write this as mu 0 epsilon 0, and the mu 0 epsilon 0 is just 1 over c squared. So we have omega squared over c squared times epsilon r. Okay, epsilon r. And we have already learned that in isotropic medium, n is equal to the square root of epsilon r. So this is omega squared over c squared times n squared. So in isotropic medium, we get this very simple relation between omega and k. And we have a fixed refractive index. Okay? However, when we consider the general situation, the anisotropic medium, we encounter two different situations. First, K dot E is in general not equal to 0. 一般来说，在 anisotropic 介质里面 ，K dot E 一般来说不是0。And the epsilon is not a scalar constant, but a tensor. Okay, so now we study the more complex situation. So now we turn back to the anisotropic medium. Anisotropic medium, and study the dispersion relation between K and omega. Okay. So, according to this equation, the first left-hand side, K cross K cross E. If I want to see the x component, 我们一个一个分量来看。If I want to see the x component of the left-hand side, okay, this is equal to K dot E times Kx minus K squared times Ex. Okay, 好，所以我们现在根据这个是我们取它的 x 分量。I take the x component of this equation. This is equal to Kx Ex plus Ky Ey plus Kz Ez times Kx. okay, minus k squared times EX. Here, kx means, k squared means kx squared plus ky squared plus kz squared, okay? So now we see that we have minus ky squared plus kz squared times EX plus kx ky times EY plus kx kz times EZ. This is the left-hand side of this equation. And the right-hand side, now we see the right-hand side. The right-hand side of this equation is equal to minus omega mu times epsilon x times EX。OK， 你就把那个矩阵现在长这样子 ，epsilon x 0 0 0 epsilon y 0 0 epsilon z 乘上 EX EY EZ， 乘出来得到的是 EX EY EZ， 对不对？那我们现在因为是采取 diagonal form， 就是主轴，所以它很简单 ，dx 直接就是 epsilon x 乘上 dx， 好，然后 dy 直接就是 epsilon y 乘上 dy， 然后 dz 就是 epsilon z 乘上 dz， 好，所以我们现在看 x component 就是得到这个东西，好，这边平方。所以我如果把这一项移到左边去，好，然后只看 x component， 我就会写出以下的结果。So the x component of the equation can be written like this. Omega squared mu epsilon x, okay, minus ky squared minus kz squared times EX plus kx ky EY plus kz kx kz EZ equal to 0. Okay. So the y component can be written as ky kx EX plus omega squared mu epsilon y minus k x squared minus kz squared times EY plus ky kz times EZ equal to 0. So the z component is also similar. Zx x z y plus omega squared mu epsilon z minus kx squared minus ky squared plus times EC equal to 0. Okay. So this relation can now be written as this. Here we have omega squared mu epsilon x, okay, minus， 我把这个改写一下啊，我把它改写一下，改成是这个减 k 平方加 kx 平方。好，因为那是减，它本来就刚刚在推的时候，其实也是这样啊，是减 k 平方加上 k。好，然后中间这里的话 ，omega square mu epsilon y minus k square plus ky square omega square mu epsilon z minus k square plus kz square. Okay, and then we have kx, ky, kx, kz. ky, kx 就是 kx, ky, kx, ky, kx, kz. Here we have ky, kz, and ky, kz. Okay. So according to Maxwell equation, we obtain this matrix relations. Now we encounter a problem. Okay. Suppose this matrix can have inverse matrix. Then if we multiply its inverse matrix, we will get zero E field. Okay. However, we want to study non-zero E field. This means that this matrix cannot have inverse. Okay, 它不能够有反矩阵。If a matrix its determinant is non-zero, then we can always write down the inverse matrix of the original square matrix. Okay, so this implies that if we do not want to have an inverse matrix, we must assume that this matrix has zero determinant. Okay, 就是它的行列式只能够是零。好，它的行列式只能够是零。好 ，so this equation, if we want non-zero E vector, implies that the determinant of this square matrix is zero. OK， 好，所以我们现在就得到一个条件，就是 dispersion relation 其实就是从行列式等于零去推出来的。啊 ，so the dispersion relation between omega and k is derived from this zero determinant condition. OK。 Now I want to simplify our notation so we can more easily to write down the determinant. Okay, so let me define AX as omega squared mu epsilon x minus k squared. AY is defined as omega mu epsilon y minus k squared. And the AC is defined as omega squared mu epsilon z minus k squared. Although these three quantities looks like three components of a vector, but they have nothing to do with any vector. These are just the three different quantities. Okay. So once I use this notation, the zero determinant condition can be written as AX plus KX squared, KX, KY, KX, KZ, AY plus KY squared, AC plus KZ squared. Okay. Here KX, KY, KX, KZ, KY, KZ, KY, KZ. The determinant is equal to 0. Okay.好，当你没有办法的时候啊，最笨的方法就是最好的办法。台湾的工程师这一方面很厉害。OK， try and error 或者是反正你没方法，就把每一种方法都试一遍，就会试出来。那这边的情况也是一样，你不用花脑筋在想说，这个行列式我有什么巧妙的方法来化解它，不用，全部展开就好，暴力展开。So now we expand this determinant and use brute force method. Okay. So we have AX plus KX squared times AY plus KY squared times AC plus KZ squared. Okay, and 2 KX squared, KY squared, KZ squared. Okay. 对，好，然后呢 ，then minus AY plus KY squared times KX squared, KZ squared minus AX plus KX squared times KY squared, KZ squared minus AC plus KZ squared. 对，好 ，times KX squared, KY squared equal to 0。好，然后再展开。那再展开的时候呢，我们就会分成有3个 A 的，有2个 A 的，有1个 A 的，有1个 A 的去展开。好 ，So we expand further, according to, we can first consider the 3A terms and the 2A terms and the 1A terms and 0A terms. Okay, the 3A terms is just AX, AY times AZ. And the 2A terms include AX, AY times KZ squared, okay, plus AY, AZ times KX squared, plus AC, AX, KY squared. And the 1A terms, plus AX times KY squared, KZ squared, plus AY, KZ squared, KX squared, plus AZ, KX squared, KY squared。其实不用去念什么佛经或什么阿弥陀佛，这个就很好啊，就是因为就锻炼你的耐心 ，OK 啊，好，然后呢，接下来呢就是zero a term 啊 zero a term 的这三个乘在一起，再加这个就3 kx ky kz 好 ，and minus ax ky squared kz squared minus ay kz squared kx squared minus az kx squared ky squared 啊，减三个 kx squared ky squared kz squared 好，然后呢？这时候你看这两排根本是完全消掉了，消啊，都消掉了，真爽啊！然后那所以我是不是还有什么东西没有？应该都消，确实是写下来了啊，所以。So finally we get this, why is AX? AX is just omega square mu epsilon x minus k squared, okay, times AY omega square mu epsilon y minus k squared, and AZ omega square mu epsilon z minus k squared, okay, plus kz squared plus kx squared plus ky squared equal to 0. Here we have omega square mu epsilon x minus k square, omega square mu epsilon y minus k square. OK, x 的话就是 yz。y 的话就是 zx， 我再3分钟好了 ，3 minutes， OK。Now we assume that k vector is omega over c times n times s. Here s S is Sx, Sy, Sz is the unit vector along K, which means K is equal S is K divided by its magnitude. Okay, so K squared is omega squared over C squared times N squared because the length of unit vector is just 1. And omega squared mu epsilon x minus K squared, what does this mean? This is equal to 这边我们还要再定3个量啊。Define